Today I will show you how to do the calculation for secondary port tidal calculation. So this is very important videos. Just stay tuned. I will show you in full details. Okay. Viewers, you can see these are the tide tables, and this is also the volume is here. You can see, and area also you can see from here. Also in the back page also you can see this is the area covered for this volume. Okay, and for this also, this is for the European waters, and this is the area covered for this volume. Okay, viewers, at the back page you can find the calculation form, guys. This one you can use also if you want, guys. Okay, and after that you can find the index of a standard port, and under the standard port all the secondary port. You see the bold letters are the standard port, and under the bold letter all are the secondary port. Okay, you can find this one here, and also here also you can find the index of the standard port and the page number. Okay, here is the index of the standard port, and here is the geographical index standard port and the secondary port also. And you can see here part 1 is for the standard port information. You can find here as per the date, as per the port name, you can find as per the day all the tidal information, time and height you can find here directly, guys. Okay, because of standard port information is given directly, but for the part 2 is for the secondary port information. You can find here because the secondary port information is not given directly, guys. You have to calculate from the standard port, guys. This bold letter Plymouth, and this is the standard port, and under this all are the secondary port. Okay, remember bold letter is the standard port and under all are the secondary port. You can understand this much. I think I'm showing you can understand this. Okay, and this is the seasonal change you can find here. Okay, this seasonal change information we need, guys. Okay, because of for calculation. Okay, and this all information we need for the time difference calculation and for the height difference calculation. Okay, you can see here this page also you can see this also here has so many standard port, and under the standard port has the secondary port, and this is the seasonal change for these two pages. Okay, and here also for this page, and also for this page, this under this is the seasonal change. Volume 3 is harmonic constant. We are not using this one. Viewers, initially I will explain this one to you, guys. This is the format. You can write on the normal paper also, no problem. And this one, you see this one you take from the standard port. Okay, before I already shown you that this is from the standard port part 1, and there you can find this for the daily. Okay, data for the tidal information. Okay, for time and for height is here. Okay, and this is the port's mouth. Our secondary port is the Hurst point. Okay, this is the Hurst point, so this is under the port's mouth. So this one also I'll explain, and this is the seasonal changes. Okay, so okay, initially I'll start from here. After that, one by one I'll explain. This is secondary port Hurst point. This is a date, time zone, UTC. Okay, this is the standard port high water time, low water time, high water time, low water time, 4 timing, this 4. Okay, I write here. And same way this height, high water height, low water height, high water height, low water height, this 4 height from here. Just I write from here, guys. If you check this one, this all standard port data I write from here. Okay, after that this seasonal change, for the standard port. Okay, guys, you see first one seasonal change for the standard port. So our standard port is Portsmouth, number is 65. So here you can find this 64 to 65 number, and this is the seasonal change according to the month. Okay, suppose this one we calculate for 21st May. So May, so you see seasonal change is nothing, means negligible. Okay, you understand how I find this one? With the number, means with the port number. You see this is the port number, port's mouth. This is the standard port 65. So 64 to 65 under this, you see here is negligible also, and nothing is here, so negligible. Okay, so I put 0. Okay guys, one more thing you have to understand, that this standard port, this minus is, you see here, and this will be algebraically subtracted. Suppose if this is minus, if here is -1 or -2, then minus minus will be plus, will be positive, remember. Okay guys, here is minus, if here is suppose +1 or +2, then the resultant will be -1 or -2. Understand, this is the algebraically subtracted. Okay, minus minus plus, or plus minus is equal to minus, like that. But this is the minus is always stay minus, but if the value is -1, then minus minus will be plus. If the value is plus, then minus plus will be minus. Okay, understand. So since this is negligible, so 0 I put. Okay, so now this is the difference. This is very important guys, this is the time difference for each time, and this is the height difference for each height. I already calculated, so that's why I write this one. I'll explain to you one by one. So before the calculation, you have to understand this one, that Hurst point. You see guys, this is the Hurst point, and if you see here, this is the high water. You see, this is the high water and this is the low water. So this 2 is for high water. Okay, so this is a port's mouth, means this Hurst point, secondary port, is under the standard port of port's mouth. So this is the high water time, these two. So 0000 to 0600 and 1200 to 1800. Okay, and this is a low water time, this one, these two, 0500 to 1100, 1700 to 2300. Okay, this is the low water time. Okay, so my high water time is 0044. So for 0044 I have to calculate the time difference. So 0044 is in between of 0000 to 0600. So 0000 to 0600, this is 6-hour interval, 6-hour difference, and time difference is this one, 0115 to 0005. Okay, this one. So the time difference is 0110. So this one I will show you guys. For first one, 0044, you see for 0600 our time difference is 0110. This is the interval, 00 to 0600 interval, the time difference is 0110. I take from here. Okay, so for 1 hour this one, and my required time is 0044. So 0044 hour time difference is this one. I just calculate here, so I found 8.5 minute. So here you see for 00 hour time difference is 0115. You see this one. Okay, so for 00 hour time difference is 0015, and for 0044 hour time difference is 8.5. Correct. So I need this one, 0044 hour time difference, so this one. And if you check here again, that 0000 to 0600, it's reducing. You see here is 0115, and towards this side is reducing, 0600 it is 0005, so reducing. Correct. So I just subtract this one from 0115, this one from 0115, subtract this 44 minute one, this one. So this one you found for 0044, 0107. Okay, or 0106.5, you can make it in a round figure because this is time. So minus 0107. Okay, so understand this one. So for 0044 this is 0107. Okay guys, I think you understand this one. So here I will make for the, so this high water is finished, I will make again for the another high water, together I will make. Okay, this will be easier if you make together. And remember, you have to calculate for 4 time also, all 4 timing, because otherwise you cannot get the secondary port information. correctly, guys. Sometime you have to do maybe for the next days also, or maybe for the before day also. Remember that can also you have to take into considerations. Okay, after that, next high water is 1310. So guys, you see next one is 1200 to 1800. So for this also the Hurst point time difference is same. Just subtract from here to this one, so 0110, and my required time is 1310. So same thing, guys, I'm doing here. For 0600 hour, time difference is 0110. 1 hour how much, and my required time is 1310, and here the time is from 1200 to 1800. 1310 and 1200 time difference is around 1 hour 10 minute. So for 1 hour 10 minute time difference, how much? This much. Okay, so for 12-hour time difference, this one for 12-hour time difference is 0115, correct? And I calculated this one for 1 hour 10 minute, so 1 hour 10 minute is this one, correct? So since this is reducing, guys, from this side is reducing, means time is increasing, time difference is reducing. So that's why subtract here from 0115 to this one, and this is your required time difference for your required time. This is my required time 1310, and the time difference is this one. Okay, so just this one, guys, just the interpolation, guys. I'm doing just a simple interpolation, just interpolation, you can understand. So for 1310, this is 0110, 0101, this is 0101. I just make the round figure. Okay, 0101. So again for the low water, guys, I write here elaborately to make you understand. Same way, guys, for the low water, I told you this is the low water side. Okay, this 2 is for high water. You see here high water, this 2 is for high water, this 2 is for low water. Okay, so low water from 0500 to 1100 and 1700 to 2300. So this is the Hurst point, this one, this two. Okay, so 0500 to 1100, the time difference is 6 hours, and my required time is first low is 0618. So this 6 hour difference, the time difference is around 5 minutes, correct? You see this one for 0600 hour, time difference is 0005. So for 1 hour how much? And my required time is 0618, and here the time is 0500. So from 0500 to 0618 is around 0118. Our time difference how much? This much I found. Now you know this is for the 0500. Okay, so 0500 time difference is 0030. Okay, so viewers, for 0500 our time difference is this one. For 0118 time difference is this one. So my required time is 0618. So just subtract, because of, if you check this way, this is decreasing, understand, means 0030, this is 0025. So I just subtract this one, I found 0029, understand, this is the low water time. So same way next time means this one 1832. So 1832 also in between of this 1700 to 2300. So same way I'll make the interpolation. Okay guys, this one. Okay, same way. I think if you understand the interpolation one, you can understand the other interpolation also. So now for the height, high water, low water, height or low water, this one also, this one I write, so this one I explain how it comes, guys. You see here, these two is for high water, this two is for high water, okay, and this two is for low water. Remember guys, okay, this two is for low water. So I will show you one. This one I do here. Suppose for first one, for 4.5 meter high water, I'll find the difference. And here you see this is the Portsmouth, and this is for the 4.7 meter. 4.7 meter is, this is minus 2.0, and 3.8 meter minus 1.5. So difference is 0.9. These two difference 0.9 and here is 0.5. So here you see I do the interpolation for 0.9 height, difference is 0.5, 1 meter height, how much, and my required height is 4.5 meter. So 4.7 to 4.5 is 0.2. So for 0.2 meter height difference, this one I calculate this one. So for 4.7 meter height difference, 2.0. You see this one for 4.7, 2.0, and for 0.2, this one I found this one. So I subtract this one because of, you see, 4.7 to 3.8 and it's decreasing, correct? 2 to 1.5. So this one is the 4.5. For 4.5 height difference, this one 1.89. okay, and same way for second high water you can calculate from here for the 4.4. guys, for 4.4 meter height, what will be the height difference? You can make the interpolation in between this. Okay, so same you can see here I do this one for 4.4 meter. If you check this one you can understand. Now for the first low water, this one, so for my low water time is 0.9. so this two is for low water. Remember, this two is for high water, this two is for low water. Okay, so for a low water is 1.9 and 0.8. The difference is 1.1, and here is 0.5 to 0.1, so difference is 0.4. so you can see here I write 1.1 meter height difference is this one for one, and for I need the required is 0.9. so 1.9 minus 0.9 is 1 meter for 1 so for 1 meter is this one. So you can find the required height. I need 0.9 is for this one. Just this is the interpolation, guys. I think you can do this one, guys. Okay, and for 1.1 meter height, same way I do the interpolation in between these two. Okay, this one and this one. Okay, guys, and the interpolation is here, guys. Okay, understand? And I write this one from here. You see, for 1.1 meter is minus 2.1. you see this is minus 2.1. okay, and guys, for 0.9 meter, for 0.9 meter is 0.14 minus 0.14 because all is minus. You see, so minus 0.14. for high water is this one. First one is 4.5 meter, 1.89, so 1.89, and second one is 4.4 meter is minus 1.83. this one, you see, for 4.4 meter is minus 1.83. I think you understand this how I bring this all here. Okay, means how I calculated this one. Same way, guys, for the time also, this time difference also I take from here, guys. You see, all timing I take from here. Like for 0044, this is the time difference, this is, okay, you see this one. And for 1310, this is the time difference, I just write here. And for 0618, time difference is this one, you see, this one. Okay, and for 1832, time difference is this one. So all I write here. Okay, understand, guys, how I write? Now you just calculate. And now here the seasonal changes you have to here add, means this is also algebraically added. So secondary port number is the first point, secondary port number is 39. So you can check here 1 to 60b, in between these two is 39. So you can check the seasonal change is negligible. Okay, so since the seasonal change is negligible for secondary port also, so I can write here 0000, correct? So I write here 0000. So now I'll calculate now here. From here subtract this one, you can find the secondary port high order time, and from here subtract this one, you can find this timing. So let's do this one. So viewers, now you just calculate. From here subtract this one, you can find this one. From here subtract this one, find this one. Just check the symbol, all is minus because of, you see, all time difference is minus, also all high difference are minus. Guys, subtract from here this one, so you can find this one. So just subtract by the calculator, you can do this one. Okay, and I already told you this secondary port is 0. I found this seasonal change here with the port number. Okay, and this is also algebraically added, but this is plus. Okay, if this seasonal change is minus, then it will be minus, remember. Okay, so if I write like this way, you can see this one. This is for 21st May. This is just assuming date, guys. Okay, so this is the data for today. So if they said you now, okay, find the height or find the time, you can find, okay, according to this, because this is your secondary port data, corrected by season, corrected by time difference, corrected by height difference, like that you find this one. This one I did in this form. If you do in white paper also, no problem, guys, because in exam you have to do in white paper. Okay, so now you can find from here the height of tide. If they given you the time, you can find the height of tide. If they given you the height of tide, you can find the time also according to the graph. Guys, this is the Portsmouth, England standard port, and this is secondary port of Hurst Point. Remember, for secondary port means under this standard port, all the secondary port graph is the same for the standard port graph. Like, guys, for the Portsmouth graph, you use for the all secondary port graph under this standard port. Okay, so under this standard port for graph, you can use the same graph. Okay, guys, remember. And remember, this is for the European water. All the standard port graph is difference. You can find in the European that tag table, you can find the graph also, so that one also you have to maintain. But for the other areas outside the European areas, there are only one graph, that is the universal curve. That one we use for the other port. But guys, for the European water, you have to use the individual graph for the individual port, and all the secondary port under the standard port, you can use the same graph. Okay, I think, guys, you understand that how I calculate this one. Just interpolation, guys, remember, just interpolation from here. This is the time interpolation for high water time, and this is the low water time. This two is for low water time interpolation, and this is for the high water height calculation, just height difference calculation, and this is for the low water height difference calculation. Okay, guys, just this much I did, and the seasonal change, and after that the result you can find for the secondary port. Okay, so guys, thank you too much. See you. Bye bye.